Welcome everyone to the University of Sydney's second Australian Circular Economy Conference and the Centre for Advanced Food Enginomics conference session dedicated to food waste in the circular economy. Before we start, I would like to acknowledge the traditional custodians of the land on which we are meeting and pay respect to the elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander. Our session will include four prominent speakers: Dr. Pablo Juliano, Associate Professor Victoria Haritos, Professor Fariba Dehghani, and Professor William Chen. After each talk of approximately 15 minutes, there will be a short 5-6 minutes question and answer discussion. Let me begin with the introduction of our first guest speaker. I'm delighted to present Dr. Pablo Juliano. He is a group leader of the food processing and supply chain from CSIRO, which delivers science innovations to the food industry as part of the CSIRO food program. Pablo Juliano is a supply chain transformation leader with strong background in innovation in food processing and food waste recovery. Over to you, Pablo, who is going to speak about high-end circular economy solutions to maximize value returns from Australians' horticultural residues.
Thank you very much, Diana, for the introduction. I'll share the screen and see if I'm successful. Oops. Okay. Is that okay? Oops. Yep. All right. So I will be talking about maximizing value return from Australia's horticultural residues, and it's more around looking at the circular economy aspects in Australia's horticulture. And with this, I will give an introduction around the National Food Waste Strategy in Australia and the targets that Australia has around that, and the quantification of fruit and vegetable losses we have, regional hubs and precincts and opportunities in this space for valorization, and some examples of company creation activities through valorization and some outlook. So I would like to give a snapshot of what has been called the National Food Waste Baseline that has been created in 2018. If you go to the Department of Agriculture, Water and Environment website, you can find a number of documents that talk about a roadmap to halve Australia's food waste by 2030. And we are talking about 7,300,000 tons per year of waste, edible and non-edible, that happens across the supply chain. Primary production, manufacturing, and households are the main ones. And that represents a $20 billion opportunity or loss. So basically, you can see the breakdown across agriculture, post-harvest processing, distribution, food services and households, and what it means. But also, that also represents losses across the supply chain in terms of inputs that go from, on-farm all the way through in terms of water and carbon footprint that occurs as a result of the waste. So some of that strategy includes some aspects of interpreting the data and looking at resources to implement that strategy. And there are aspects of most preferred to least preferred, and aspects around preventing, reusing, recycling, recovering, and disposing. And you can see the amounts that go across the supply chain into the different streams. But when you go on farm and at farm levels, then the appetite is to go in the other direction from the most preferred, and the question is more, how ready is Australia to take on this waste and transform it and prevent and reuse, and what are we currently doing, and how ready are companies to take on that opportunity? This is a lot of information, but it's just to show you there is an actual roadmap that has been launched last year. And you can find it also on the website of the Department of Agriculture, Water and Environment. And that actually is having a number of initiatives that are occurring. And part of that is FIAL's effort to look at that baseline and revise the baseline again. and then coming up with a voluntary commitment program for companies. So part of that baseline, and here you can see the new baseline and the old baseline, giving some of the numbers, and this is for primary production losses. And it shows significant wastage in fruit, nuts, and wine grapes, vegetables, and broadacre crops. And at CSIRO, we've been taking some focus on fruits and vegetables and to understand the losses at that level. But also, if you look at the manufacturing losses, you can see fruit and vegetable in pack houses and winemaking as being one of the major waste producers, you know, as a result of processing, but also you have dairy manufacturing as another one. So I will, in this presentation, I'm digging more into the aspects of fruits and vegetables. And what we did was taking a national survey on-farm and pre-retail, which means on-farm packing houses and in basically manufacturing, and looking at the regions and basically agglomerating the data on a regional level. And this is a study that is quite unique. Countries have not done regional level positioning of food losses pre-retail. And what we are showing in this map is the level of amounts that happen in different regions in Australia. Some government and industry initiatives that are happening, and I won't have time to cover over this, but there are some of the major retailers and FIAL and Food Waste CRC looking into this, and there are some programs, you know, from Aussie industry I will talk a bit more about. If you look at the major crops that are producing this loss, we found that wine grape, potato, tomato, and orange are the ones, and we have that on our report and on our CSIRO website if you want to dig into more detail of that. This is a lot of information, but all I want to say is we have also broken down by which are the key crops that are producing and where are these being produced. So you can see the tonnages that happen at primary production, the tonnages that happen at manufacturing, showing that wine, potato, and orange as our major ones. Of course, this data needs further validation and granularity, but there are a number of assumptions we had to make, and taking cross-reference data and extrapolate, but we came with the best that we, numbers we could get in terms of kilotons that happens. But you can see that there are state predominance for some of these crops, and also CSIRO at the moment is taking an initiative around developing Northern Australia, and we are in conversations in looking at opportunities with some of the crops that are shown in blue in terms of valorization as well. So I will just show a video that is also showing a concept around what we call the food loss bank and the opportunities for regional hubs.
We are on the precipice of a global food challenge. There are already 800 million people in the world today without enough to eat. And with the world population set to hit 9.7 billion by 2050, the problem of malnourishment is only going to get worse. This isn't helped when 1/3 of global food production is wasted each year. This waste leads to food insecurity and the deterioration of natural resources. If we want any chance of averting this disaster, we have to change the way we deal with food. This means developing sustainable mechanisms to give people the nutrition they need. At CSIRO, we're revolutionising the supply chain by creating a food loss bank. Our food loss bank will form a decentralised network. Intelligent sensors will navigate various stage gates along the way to make smart decisions for our future. The network starts with the farm, where we'll collect edible biomass that is discarded or lost to the food supply because it is diverted to non-food uses. This biomass will be taken to automated manufacturing hubs, where it will be deconstructed into high-value functional food ingredients. Once safely processed, we'll reconstruct these value-added ingredients into nutrient-dense food products, ready to hit your local supermarket shelves. But this is just one step in the food revolution.
Oops. Okay. So there's another part that, yeah, the video didn't go through, but there's another part that talks about personalized nutrition and opportunities in this space as well, with certain ingredients. So how do we basically take that hub concept that seems quite ideally? Well, there are different ways of valorization, and you can start by, you know, value capturing with processing level, you know, by washing, engraving, but then you have a number of alternatives of transformation through food processing that can have greater technical complexity, greater investment as well in marketing, and different increase in output value. So you can see that based on the products that we target, the price per kilo is going to increase, but also the benefits are going to be greater as well. So these are some processing strategies that we've been looking with CSIRO around a Hort innovation project that happened for 2 years, and now it is continuing with other initiatives. So it's aspects of taking the vegetable biomass, stabilizing. You can either dry it into a powder, you can put this into extrudates, we can make fermentation and fermented products, or we can do, and we can do extraction as well. So that's a number of options that we can do. So what we have done is creating what is called this regional food processing hub concept, where we are looking at, you know, what is the market pool for these products, and looking at opportunities for centralizing that regional hub that will give you a set of products that can be bioactives, concentrate powders, bulk stabilized products. But now we are bringing that circular economy dimension around other bioproducts that could be fertilizers, that could be textiles, and look at how all of this fits in together into that equation. So it would be aspects coming from farm, aspects coming from processing, and products that will go into beverages, packaged food, and supplements. But also we need to consider the fact that the realities are we have more sensors and opportunities of value capturing and data capturing on farm that can connect into supply chains and give information about the raw materials happening in this and what goes into the factory basically. So Industry 4.0 is an area of interest that we are trying to do, and then basically we have at government level there are some industry opportunities that and recently there's the entrepreneurs program that is looking at food waste, and you can find some links at the government. There's $500 million going into on-farm manufacturing and transportation projects that support companies for this. Something that CSIRO has recently launched is a new company, and we are taking this as company creation opportunities, which is that project came to fruition into creating 4 to 5 health star rating powders and also snacks, for example, broccoli or from other vegetables that are high nutrient dense, and they have, you know, at least 1 serve of vegetable in a snack. And there are other aspects of valorization into this. So, for example, in broccoli, you have the stems and the leaves that are left on the ground that can be recaptured, and the out of spec materials that can go through a pre-processing and a fermentation process, and that actually is increasing antioxidant capacities, increasing fiber and protein, and we have demonstrated that it can be done through fast fermentation through selected cultures. And there are opportunities to also increase the nutrients into those materials by adding some omega-3s, for example, through microencapsulation processes, and trapping this oil, because we have, for example, broccoli and cauliflower having 30% protein, similar to milk powder, and opportunities to divert into a number of product applications. There's other companies as well, such as Natural Evolution, looking at resistant starch, looking at gut health, that is coming from 26,000 tons of bananas that are being lost, and that have been turned into an opportunity, and then you have that in the market. And in the grape mark area, which was one of the ones, the supply chains that we found being a largest waste producer, we have companies already servicing the wine industry through grape tannings, and other projects through the CRC around grape extract going into grape seed. At the moment, Australia is importing the grape mark to make those extracts, and there are big opportunities in this space as well. So in a nutshell, there's a lot that we can do, and we can look at, you know, the regional biomass going into what we call nutra-food, high health driven nutrients recovery. But also we need to consider the aspects of energy, soils and fertilizers, textiles and biomaterials, and aquaculture and products and animal feed. So how do we put all this together into a circular economy bit? And this is something we're working on. We have some innovation enablers such as aquaponics, insects, synthetic biology, opportunities, separations, food processing, and biochemical processing. So basically here you have different routes that you can take into taking that biomass and turning it into circular economy opportunities as well. So in a nutshell, we are working on this progress in these $20 billion opportunities for valorization. We talked about 1.5 million tons lost of fruit and vegetable pre-retail. We are contributing to this national food waste roadmap, and there are great opportunities for you know, market pull from fruit and vegetable ingredients, particularly as Australians don't have enough fruits and vegetables, and that can go into nutrient-dense foods as well. So we have some new companies looking at increased vegetable servings per product, on-farm processing or valorization networks, aspects of drying technologies going on farm, and other aspects of integrating different technologies into this. So I would like to acknowledge a number of people that are behind this and have worked and are currently working into this area, and I would like to thank you for your attention.
Thank you, Pablo, for this lovely presentation. Any questions from our audience? Before anyone asks something, may I ask you, you mentioned that some of the produce that you're currently trying to develop are fermentation products from, particularly you were showing from broccoli. What is the exact application of these fermentation products? So what can be further used of this?
So, yeah. So we have, I mean, as you know, we have some in the market. There are the kombucha has kind of take rise, but this is just one product, you know, that beverage aspect. But there's all these aspects of isotonic drinks, aspects where you need antioxidant increase. There are you know, kids meal. It could go into kids meal. It could be ingredients that go into other food products, sauces. You know, it's all around bringing those antioxidants into different food products, and it could go into pastas, it could go into bread. So there's a number of things where a system where you can preserve that either prebiotic or probiotic opportunity as well in this space through fermentation. So there's various applications in there, and we are looking in this through NutriV as well.
Yeah. There is people asking for a copy of your presentation, and there's a questions from Melissa Lechnicht. It strikes me as complete madness that we are importing an ingredient that is a high waste product in Australia. I think that she's mentioning about the grapes thing.
Yeah.
And
so, no,
yeah, it's
no
just
problem.
a comment. And There is another one from Nicholas Bedford. There was mention on using food waste for energy. Can you expand this concept? What research gap do you see in this area?
Okay, so yes, slides can be shared, no problem. In terms of yes, I fully agree, Melissa. This is the way it is, and sometimes it's about getting producers better organized and getting the systems in place, and the logistics and the costs. So cost benefit analysis are fundamental in the equation, and this is sometimes what reigns the way we do things, and that's why we are having initiatives with state governments, and the CRC actually is working in that space, and we are trying to go more national around those opportunities to ensure that we close these gaps. In terms of energy, yes, I mean it's not my core area, but we are looking at novel opportunities for hydrogen production or other opportunities where you can have bioreactors that are basically going to give you some inputs into that. So there's and it's basically it's something that we are looking into. I'm not an expert in that, but definitely there are aspects of creating biogas through food waste that can go on farm, and there are systems that you can put on farm to do this. And again, it's circular economy, so it needs to be economically feasible to do it and integrate that.
There are other questions. Sorry to interrupt you, Pablo. There are other questions coming. If we have 3 more minutes to answer them quickly. So the first one is, what is the time frame to get innovations up running? All the innovation you mentioned. This is from Amanda Kane. And the next one is it scalable to utilize food waste as fertilizer to provide nutrients to soil in growing areas? And there's one last, which I'll mention after you answer quickly these two.
Okay. All right. So, sorry, it cut off a bit, but if I got the second one, so which is basically around aspects of fertilizers. So yes, that's an area that agriculture and food at CSIRO is looking at, and opportunities to make the right fertilizers with certain food waste. So this is clearly an opportunity. There are composting industries such as pit soil that are currently doing this, and they are selling that pelletized fertilizers, but there's much more to be done to get it right, let's say.
Yeah, the next question is from Martin Stewart. From the data you presented, the biggest area of opportunities in recovering household food waste. This is an area he's interested in. What innovations are you having in this area?
So at the moment, I'm aware that OzHarvest, for example, as well as Food Bank Australia, are really looking into this opportunity. There's an increase of 46% in demands for food relief. So that's the first aspects of how do we do that on a retail level, but on a household level. It's also there are other council initiatives around putting it all together and turn this into energy. So I'm aware of opportunities in Melbourne that are happening in the space in certain councils.
Yeah, thank you very much, Dr. Pablo Juliano. We have to move on. I'm pleased now to introduce our second guest speaker, Associate Professor Victoria Haritos. She's a Deputy Head of Chemical Engineering at Monash University. Associate Professor Haritos' research brings together biology and engineering to address future sustainable manufacturing needs. In her research, Associate Professor Haritos discovered and designs enzymes for specific and fast reactions and applies as a biocatalyst in metabolically engineered yeast and bacteria for the production of lipids and alcohol. Welcome, and over to you, Associate Professor Victoria Haritos, talking about virtually no food waste, only value.
Thank you very much, Diana, for the introduction and for the invitation to come and speak with the audience today. So welcome everybody, good morning, and it's my pleasure to share with you my thoughts on food waste and what we might do about it. My title is virtually no waste, only value, in honour of our virtual conference here. And what I'm going to talk about is a little bit along the same lines as Pablo, but perhaps more at a more practical level. So I'm going to be talking about how we look at constituents in wastes, how we convert them, just briefly touch on those. Talk about opportunities to waste, similarly to where Pablo was at. Some product value and volumes thoughts, some considerations that you need to keep in mind when you're thinking about waste and whether you want to valorize it. And I'm going to give you some successful examples and just touch briefly on some research we're doing at Monash. So it's a very general talk, I understand, for a very general audience. So first of all, I guess the question you have to ask yourself is, you know, why do you want to convert food waste into something? Okay, we all would like to be sustainable, but there could be a whole range of reasons that people will come to this question. Okay, so not only from a point of view of sustainability or a genuine belief in circular economy. Okay, so there's a whole raft of reasons why you might want to do this. The way, you know, I generally approach the question is to think about this waste, and I think about its constituents. I think about, you know, I sort of mentally pick apart what it may well have in it, and think about then what sorts of things the product's going to be most suitable for. So, you know, what sorts of value lie within that waste. And if we look at those list of components there, you know, proteins, we understand proteins, but they can be from very, very different sources, like a whole raft of sources of them. We've heard quite a bit about vegetables and fruits from Pablo just now, but within them, they have a whole lot of different constituents. You know, what within them is of value? And if you look down the list there, I'm not going to go through them in detail, but just to say, we don't just see the whole thing, we think about it in parts as well to see whether there's transformation or extraction of value from that waste. And indeed, as Pablo also mentioned, there are a real lot of tools available to you to do the conversions or extractions. Okay, you've got physical methods, you've got biological methods, you've got chemical methods. You can use these in your matrix to think about how to work with those constituents of the waste to either transform or extract value from the waste. So, you know, depending on the suitability to the task that you're asking, you have a lot of choices and these are all things that can be done at scale. When I think about a waste, I think about where it is in terms of processing requirement and values. So we started talking about this in Pablo's talk just now, but you know, if you're looking at the sort of landfill end, that's where the cost, you know, that can cost you, what will cost you. Anything above that, any sort of processing above that should deliver you some value. But these come with different processing requirements. So the highest value products often will require the most processing. Okay, so if you're going to go for something really high value, natural flavors and colors, for example, you will probably need to do a lot of processing and purification of that product for the end result. But you have a whole raft of choices lower down that may be better suited to your processing requirements or what's available to you and the values that you're seeking from your waste. So as you can see, there's a whole range of different sorts of things, from animal feed to food ingredients to extractives. We'll talk a little bit more about some of those in a moment. So what do I think about? I think about where they lie on a value volume curve. This is just a sort of conceptual curve that has volume of production on the x-axis and value, arbitrary value on the y-axis. So we have at one end low volume, high value products like nutraceuticals or pharmaceuticals. These would be like omega-3 oils, or we saw that grapeseed extract in Pablo's talk. And so up at the high value end, but low volume. Then conversely, we'll have at the high volume, low value end, commodity products, okay? So some food oils, some pectins, you know, maybe some of the products going into bioenergy will be down this commodity end. But then you have items that will sit along that value volume curve towards, you know, in the middle, and you can see a lot of familiar sorts of things that you might extract from food waste here in this mid-range. So these are, this concept, this value volume curve, is really good to put into your mind whether you're, you know, are you going to be making something of high value at low volume or high volume at low value. So you have different risks or different things you need to think about when you're going to work at different ends of the scale. At the commodity end, you're going to need plentiful, low-cost feedstock. Otherwise, you won't be able to sell your product cheaply, and it won't be competitive. At the high-value, low-volume end, you're going to, if it's going to be something like a nutraceutical, you might have regulatory hurdles. So you might need to have a regulatory data set to actually get this approved. You also could risk market saturation because the volumes are very low at this high value end. So, you know, beware of competition at that high value, low volume end, and think imaginatively about how you might increase the volume of your commodity product by working with others who have similar product that may be produced at a different time of the year to you. So some of these sort of grower area concepts that Pablo was talking about is perfect for that sort of situation where you may be able to contribute to a pool of waste. So moving along and thinking then in an overview about the waste and product considerations. So if we focus on the right-hand side at the moment and think about waste, what are sort of the things that you might need to think about in a systematic way before you start your valorisation of your waste? How perishable is it? How stable is it? Because you might need to have to process it straight away. Where is it located? If it's miles away from everything, the cost of transport is going to be horrendous unless you do your processing on site. What's the volume you're going to produce? How sustainable is this product? How available is it really? Are there some other people competing for that product? Okay, so there's some of the things you need to think about from the waste side. Then on the product side and the processing side, what sorts of, you know, what sort of technology are you going to use? How readily available, scalable is that technology? What are the values and volumes of that product? What are the market segments? Do you know about that market segment? Do you know anything about omega-3 oils or nutraceuticals? What's the potential for competition for your product? What are the sort of capital costs going to be to get this thing processed? Do you need regulatory approval? Do you need value chain partners? Okay, so these are the sorts of things that you need to keep in mind when you're really going to launch on doing something with your waste. I'm going to give you some examples now of some very familiar ones and some ones that may not be so familiar to you, to show you that this really can be done, and we've been doing it for many years in Australia. So for example, we've been transforming tallow and used cooking oil into biodiesel for a very long time, you know, so and it's still going on. Here's an example of a company, Just Biodiesel, that are doing that right now. Wilmar in Queensland have been making ethanol from sugarcane molasses for a very long time as well. There's another example of these things have been around for a long time. And they're both examples of an energy use in energy of these waste products. NH Foods have been using meat processing byproduct for a whole range of different uses. And we've had examples already from Pablo about the dairy industry, but we have to say that the cheese whey processing products, making protein powder isolates and pharmaceutical grade lactose from those is a genuine story of turning waste into value. These are well established. Some newer innovations for a company called Bigger Bionutrients. They're now extracting, they're doing advanced separations and now extracting out high value products, high value pharmaceuticals that require regulatory approval from dairy byproduct. So moving into the more high value area. Two examples from the cosmetics industry. One is an extract from grape, from grain, and one from grape. And using different sorts of technology, you can get these chemical intermediates come from natural sources, which then go into these very high value cosmetics. Okay, so this is an example of those very low volume, very high value products. No regulatory approval. I already had this example from Pablo. I think it's a tremendous example of banana waste and how it's been turned into you know, a gluten-free prebiotic paleo flour, and has been a big success. It's also made with this resistant starch, which makes it an even healthier flour to use. Brewers Spent Grains, a company in the US this is, who've recently developed a new process for making protein powder from their Brewers Spent Grains, using all water-based. Very, very nice process, and a very big hit for their product. But there's another waste product turned into value. Another example from Australia is the making of sort of medical grade chitosan from chitin, which has come from seafood byproduct. Okay, there's a process shown here. This has taken R&D and collaboration with industry, but they're getting there. They're making it. This is a pharmaceutical grade product that will be used for adhesives and bandage and eye repair. And just finish off by telling you a little bit about some of the work we're doing at Monash. So I certainly in my group have been working on food waste for a while now, and we have current projects around vegetable fibre, looking at the waste from legume processing and winemaking byproducts. Different product that Pablo was talking about, but a similar problem that we see. There's a very large amount of great wine waste sitting around that could be better used for high value products. Also, I'd like to alert you to an excellent team of students who are working, have a team called Monash Fuel from Waste. They've actually developed and are continuing to develop a process where they take food waste from the campus and use enzymes to break that down and then feed the product to yeast, which make fat, and they turn that fat into biodiesel. So this is a passionate student team who are right into that circular economy idea, and they're doing really great work. And I just want to finish off by saying, you know, there are really clear opportunities. I've given you just a snapshot of some examples of where there are processing methods, and you can be successful in taking waste to high value products. There are broader considerations that you really need to take into account. I've given you a bit of a rundown on what some of those are. You can't just launch into this, go, I'm going to make that. Okay, there's a bit of thinking and planning to be done around that. And it usually requires research and development and capital investment to achieve that. So be very happy to take your questions, and over to you, Diana.
Thank you very much, Victoria. Any questions for Victoria? Before they start asking questions, could you please elaborate more on this intriguing project of your students with the cotton?
Sure, sure. So we have these student teams that are based in engineering, but involve students from all over the university. They are mostly undergraduates, but they're looked after by a couple of postgraduate students. They take food waste, look at the moment, it's mostly food waste that's either vegetable-based or fruit-based, and they're using enzymes to break that down into sugar, and those sugars are fed to the yeast. And it's a natural yeast that is food-friendly. They form very large lipid globules in the cells, and they're quite easily broken apart, and then that lipid's used to convert to biodiesel. So yeah. They're a passionate bunch.
Really good. Any questions for Associate Professor Victoria Haritos? Please jump in. Also, I would like to say that our last speaker, Professor William Cheney, is running late, so we may have extra time for questions, so you could stay with us till the end. There are outstanding questions for you, Pablo, so you may have the opportunity to answer this later. And I think there's a question now for, what is the biggest hurdles you see in commercialization of this initiative? Victoria, this is for you.
Yes, well, that's an interesting one. To be honest, the biggest hurdle is making sure it's economically sound. I think technology is there, pretty much scalable technology is there to tackle most challenges. The challenge is often economic, and so that was why you need to be very careful about what value you can get from your product and look at competition and that sort of thing. So there are ways around thinking about competition. So there's some good advice to be given there, but I think that's your biggest hurdle.
This was the question that you answered was from Martin Stewart. And now there's another question from Chris Rose. Have you looked at utilizing household used cooking oils for biofuels or only commercial cooking oils?
Household, commercial, they're all pretty much the same. They're made of the same ingredients, and sometimes the household version of the oil is probably cleaner than the more commercial versions. And yes, you can very easily make biodiesel out of household cooking oil. We don't exactly, but it's certainly been done.
Yeah, another question coming. This is actually a little bit more from Chris Rose. Interesting. I wasn't aware of any schemes in this space. If you know of these schemes, could you please tell us? And
so of
the same scheme with the cooking oil, commercial cooking oil, and household utilizing of household oil.
Right. Schemes. Sorry.
Scheme,
oh, okay. I was probably referring more to, you know, people having done it on blogs or that sort of thing. So, yeah, there's probably plenty of information out there on how to do it. If you're that keen, by all means, contact me. I'll put you in the right direction with how you can do that safely, with safety at home. Okay. But you know, also you've got to think about if you're going to put this in a motor that you care about. You've got to be very careful about your specification of how the fuel comes out. Okay.
Yeah. I don't see any other questions, but I think that they'll be probably coming through as they were for Pablo. And now I have to thank you, Associate Professor Victoria Haritos. And now I'm thrilled to introduce the University of Sydney Centre for Advanced Food Enginomics Director, Professor Fariba Dehghani. Professor Dehghani leads a multidisciplinary bioengineering research team focused on different aspects of regenerative medicine, tissue engineering, and biomaterials, nutritional food products, and developing new food technologies. Professor Dehghani is distinguished researcher and was recognized by Engineers Australia as one of the nation's top 50 engineers for innovation. Over to you, Professor Dehghani.
Thank you, Diana, for the introduction. I think after talking by Pablo and Victoria, I think they make my life easier to talk about food waste in circular economy. I would like to give you an overview of our research during the last 5 years in the area of food waste and circular economy. In our Center for Advanced Food Enginomics, while we are looking at how food structure affect and food engineering affect food and food structure affect the food bioavailability, digestibility, microbiota, and our health and well-being, we're also looking at the level of technology that promotes a sustainable food system and looking at minimizing food waste and improve circular economy of food. Our research is basically aligned with the United Nations Global Agenda on Sustainable Development Goals and protecting our planet, looking at how we can basically feeding the large population growing and reaching to 10 billion by 2050 using different sources of protein and protecting the planet while we are producing the food for prevention of the malnutrition and hunger worldwide. And as you know, one of the major problems, as Pablo said, and also Victoria mentioned, food waste is a major problem globally, and from 654 million tons of food that we produce around the world, 30% is wasted during the production, transport, processing, and trade, and also by consumer, as Pablo mentioned that. And now I wanted to give you examples of collaboration that we did with different industry and how we consider about using this food waste, producing some high value product and added value products. The first work was in collaboration with Lang Technology that produces orange juice and other type of juices. And we all enjoy drinking juice, particularly in summertime. But we need to know that around 50% of the fruit is wasted during the landfill, in landfill, and also 30 to 40% of total weight of the orange is basically during the production of the juice is wasted. And this orange peel and flesh is actually a source of phytochemicals, and we wanted to see whether we can use this waste for high value products. In our research, we wanted to look whether it can have anti-cancer activity, and we designed an analytical technique and assay to see whether actually this extract from the orange peel can prevent the cancer relapse. And for doing that, we first looked and found that actually this extract from the orange peel can inhibit the cell viability, and by increasing the concentration, it is much more obvious, as you can see here. And then we also, in this assay that we developed, we clearly could see that this orange peel extract can inhibit the cell, entering the cell cycle and remain in the quiescent state. And this basically gives us hope that basically this extract from the food waste extract can be used to reduce the risk of cancer recurrence, and it can be used for fortifying food in future. And this can be hope for the people who has cancer and go to the chemotherapy. If they take this type of food, potentially they can reduce their cancer recurrence. The second work that we have done is in collaboration with another company, PCA, that produces peanut. And they have two problems in production of the peanut. One problem is during the extraction of the oil from the peanut, they have huge amount of milk which produce from this peanut oil production. And another problem that they had, the fungi grow on the seed, and they significantly decrease their yield of production of the peanut. And they were using currently the pesticides that to control that fungal growth, but it was actually not that much effective, and also has concern about human consumption after that. What we came up from this project, we basically looking at how we can use this waste from the company as a nutrient for fermentation process. And by this precision fermentation, we could actually produce natomycin, which is a naturally occurring antifungal compound and broadly used by industry, and it is very effective against fungal plant pathogens, and it doesn't cause resistance, and it has negligible toxicity to against human. And it can actually protect their seedling and increase the yield of the peanut production. And this is basically successful for the company. And we actually show that when we produce this product by fermentation, this natomycin, the product is much more effective than current pesticides that they use in the company. We all enjoy having, cherry tomato every day in our salad, but the company Perfection Fresh, that is one of the largest producers of the cherry tomato, has a problem of waste, these leaves that are around these beautiful cherries tomato cherries, they don't know what to do with these leaves, huge amount of leaves that are produced by the company. In our research in collaboration with this industry, we found that these basically leaves of tomato is a rich source of the protein, polyphenols, and also vitamin K1 and solonosol, which is a precursor for production of coenzyme Q10, which is a very complex molecule which cannot be synthesized easily, but by extraction from tomato paste, we can actually have this solonosol, and it can have lots of health benefits. In addition to that, if we can produce vitamin K1 at a low cost, it can prevent cardiovascular risk of cardiovascular diseases and also osteoporosis for the human. And it can also, if it is very low cost, we can use it as an alternative for giving to the chicken that lay eggs, because currently for prevention of the hemorrhoidal disorder, they give menodione, which is a synthetic form of vitamin K, to the chicken. And it actually, menodione decrease the bone density of these chicken, and they will have bone fracture during the laying eggs. But we demonstrate that by using this low-cost vitamin K1, we can actually increase the bone density of the chicken 5 times. And this chicken can produce more eggs. And also this vitamin K can be transferred to the egg yolk. Basically, it has 3 benefits for both for consumers and also for the supplier of the eggs. Collaboration with the Abbey Mori, which produces yeast. Again, this company has a problem for wasting a large amount of the fermented product, which is a nutritious, there are lots of nutrition in this waste. And we were able to design a process for the company to recover the salt from this waste product. And this salt could be used as a fertilizer, and the other byproduct could be used for production of energy and methane. One of the major problems in the food supply chain is use of huge amount of plastic container for delivery of the food to the consumers. And this makes a negative impact, huge negative impacts on our environment. One of our area of research was focusing on how we can actually minimize usage of the plastic containers, rather than using non-degradable plastic. I know that we can do recycling, but is there any other way that we can produce, for example, biodegradable polymers, and also improve the food shelf life by reducing, food waste, if we can do increasing the food shelf life. For this area, we were working on production of 2 different types of polymers and make them potential to be able to be used for food packaging. One of these polymers is PHB, polyhydroxybutyrate, which is produced by food waste. You can use the food waste to produce PHB by fermentation. But the problem with this polymer, PHB, is very brittle. And we actually designed a new plasticizer which can be combined with this polymer and overcome the problem of the brittleness. And now we can use the food waste to produce a biodegradable polymer, PHB, which can be used for food packaging. Another polymer that we were focusing on production is polypropylene carbonate. And this polymer is produced from converting CO2 to this polymer. Basically, you can use CO2 and a catalyst to convert it to polypropylene carbonate, which has a very unique properties. And it can be degraded to carbon dioxide and water, and without having any impact on environment. One of the problems that they cannot use this for food packaging is the remaining of the residue of this metal catalyst in the which is used in the polymer processing. What we have done, we have designed a process, a benign process, which can basically use high pressure CO2 plus water to make acidic water and extract the catalyst from the polymer and remove 90% of this catalyst from the polymer and improve the mechanical property and degradation, thermal degradation property of this polymer. As you can see in here, by reducing the composition of the catalyst and other byproduct, the thermal degradation property of this polymer is significantly improved. And also we can improve the mechanical property of this polymer. And this polymer, this PPC, has much, very similar mechanical property compared with the low-density polyethylene that is currently used for food packaging. And the most important thing is the barrier property of this polymer is much better than low-density polyethylene, as you can see here. It doesn't have that much permeability to oxygen and also water, and then it can, if you use it for food packaging, we can improve the food shelf life. And to increase the food shelf life, we also demonstrate that this polymer is safe to be used for packaging of low temperature, low pH or high pH, basically acidic or alkaline solution, and also even the solution which contain ethanol. Then it can be used for packaging, juices and many other type of the food products. This polymer can be easily degraded in compost, basically by bacteria, enzyme that produced by bacteria, but it doesn't actually degrade if you don't have the bacteria in the soil, and the molecular weight gradually decrease. And if we wanted to have faster degradation, we actually can add some additive, other natural products such as starch or cellulose to the polymer, and you can see that the degradation can significantly increase if we add this type of the natural filler. And to increase the food shelf life, to decrease the food waste, we actually can make active packaging from PPC by plasma treatment of the surface and addition of the naturally antimicrobial compounds such as thymol. And this basically gradually this active compound can be released from the polymer surface, and we have demonstrated that it can have antimicrobial properties. Another way to minimize the food waste, as Pablo said, to give decision-making tools to the consumers and of course the supplier. And we are working on this area to design sensors which can give information to the consumers, and also, as I mentioned, to the supplier of the food, designing colorimetric sensors or chemoresistive or electrochemical sensors. This type of sensors can give information to the manufacturer, distributor, and also retailer, and also shopper, consumers, how to find the rather than using expiry date as a detection or system for detection of the food spoilage or degraded food production, we can actually give another powerful tools to the consumer to make decision when is the time to dispose the food. The current sensors which are used for detection of gases or other type of microbial contamination are very rigid and need several steps, are sensitive to water, they cannot work under humid environment, and they need high power and energy to work. And these are not suitable for food packaging. And what we need to do, we have to make very low cost, basically sensors which can be soft and flexible, and they can work under wet environment, and they will be safe for the human consumption when exposed to the food. And in our research center, we were able to design sensors which are flexible. They can actually work under the water environment. They can be changing the color to give information to the consumer. and they can actually work wireless and give signals for the detection system. And for example, we design also sensor which can detect ethylene, and this can give information when the food is ripened. For example, avocado or banana, or for example, kiwi. And these are areas that we are working to basically design systems that can give us information and making decision to minimize food waste by whole supply chain. One of the problems is for designing sensors is you have to make sure that they can work at different temperature that we store the food. And sensors that we design actually can work at room temperature, at fridge temperature, and also minus 20 degrees centigrade. And it is sensitive to only we can design the system in a way that it can detect only the gas that we are interested to detect. And it is also sensitive at different, ammonia, for example, in this case, ammonia, we can define range of the, concentration that it can change the color. And it can be used for detection of the contamination or spoilage of the food, such as meat, a different type of meat. And now we are working to design biodegradable, low-cost polymer and even sensors which can be added to the paper and decrease the cost to make sure it can be applied to whole supply chain and give information to everyone. And I would like to thank our team, Center of Advanced Food Enginomics, which are all involved in this research that I presented today. And thank you very much for your attention.
Thank you, Fariba, for this presentation. Please ask her your questions. We have one question from Chris Ross. When you talk about orange peel, are you referring to the oils, or are you able to break them down to other nutrients?
Yes, I mean, we can use orange peel to produce fibers and also other active compounds, We can do the fractionation, and we basically looking at oil extracts and also water extracts by using just hot water.
Yeah. Any other questions for Professor Dehghani? Yeah. When we're waiting for questions, I just need to mention, okay, there's one. Thank you to the panel for a very informative session. People are thanking you, and we are waiting just Professor William Chain to join us. He's having a technical difficulties at the moment.
Yes, he's trying to log in. He sent me a message.
Yeah, so I think that this will be sorted in a second. Okay. So any other questions for Professor Dehghani? Please place them in the chat or in the questions and answer sessions. Yeah. So this message I'm here is from Professor Chen or not?
From Sandra, I think it wasn't. Maybe
yeah, I can see from Sandra, but I think that probably he's not sure. Okay, so question for all panelists. Are there any current framework for measuring the most viable use of things like oranges and used oil? People are still interested in the oil peels. So Fariba?
Sorry,
so are there any current frameworks for measuring the most viable use of things like oranges and used oils? And also the other panelists also can answer, they said, to all of you. There seem to be some cases where there are many uses. This is the continuation of these questions from Chris Ross. So Pablo and Victoria, you can also include yourself. Yeah, and now we have
William from Singapore in here, but yeah, maybe you can ask him to share the screen.
Yeah, I'm not sure. I'm not sure if he's there. Yeah, now we can see him.
Okay,
Good.
Okay.
Fantastic.
Someone
Fantastic.
unmute me. Yeah. Can you see me?
Yeah, we can see you. I think that you're using, but so we have just one more minute. So with regards to the sensors, this is a question to Professor Dehghani. With regards to the sensors, how close are they to industry applications? Are different sensors for different foods further down the research and production line than others? This is the last question for you, Fariba.
Yeah, we are looking for industry partner to collaborate with us, but we are working on making multiple, sensors in one, and but it's still under the research. We have received the ARC linkage grant and discovery grant, and we are working on this area to hopefully make it feasible to go to the market soon. Yes.
Yeah. And now, as we know, we have Professor Chen joining us. Thank you very much, Professor Dehghani. I'm delighted to introduce our final speaker, Professor William Chen. Professor Chen is a Michael Pham Chair Professor and Director of Food Science and Technology Program at Nanyang Technological University, Singapore. Professor Chen's research is highly interdisciplinary, with a strong focus on platform development for food tech innovations. Professor Chen talking about innovations for zero waste food processing and circular economy. Over to you, Professor Chen.
Hello. Good morning. Can you see the screen?
Yeah, you can see.
Okay. Good morning, colleagues from University of Sydney and Australia. Thank you very much for inviting me to take part in this very important and a meaningful conference. So I would like to share with you the perspective from Singapore, a small city-state. So I'm from the Nanyang Technological University in Singapore. I visited Professor Fariba in the University of Sydney before, and Sandra has been to Singapore a number of times, so we have some close interaction in terms of collaboration in the food space. But today I would like to share with you our effort in the moving research and innovation in the direction of creating food circular economy. So this is a slide indicating the Singapore Food Security Index. Surprisingly to many, we are ranked top in the world. But as if we look at the matrix of ranking, actually is based largely on 3 criteria. One is affordability of food. Second one is availability of food. The third one is quality and safety. As you know, in Singapore, we import more than 90% of food from more than 180 countries. So the availability is not an issue until the COVID-19 hits the world. And as governments is very much pushing for proper nutrition, and which is affordable to most residents, all the residents in Singapore. So for those who have been to Singapore, you know that the food is largely affordable, unless we eat the modern steakhouse every day. And the food is very safe and high quality, because we have this Singapore Food Agency. They have this framework to ensure the food is safe at the retail end, in restaurant and eating place. But there are a lot of underlying risk factors. First one is, as just mentioned, we import more than 90% of food. Second one is we talk a lot about the impact of climate change on the agriculture. But this is like a fall in the slowly heating water. We see news around this the impact at the various parts of the world, but there's no direct impact on our daily life in terms of food availability. But now we talk about this ongoing COVID-19 and its impact on the food supply chain. Then this is very real, because for Singapore, we import so much food, and this COVID-19 directly hit the food supply chain. So we feel the impact immediately, although the food is still available. But this is something we have to address, because one day we will have money but no food to buy. Yeah. So Singapore government has recently pushed out this mission called 30% of nutrition requirement from local production. So is it achievable? Is it too low, too high? To give you a sense of a reality, let me move to the next slide. This is a situation in Singapore right now. You can see that when we talk about food security, there are three different aspects. First one is we actually do not have, it's a small city state. How small it is? It's a 700 kilometer square. It's smaller than many cities in Australia. How much land do we have for agriculture? Less than 1%. So that makes our 30% target very challenging, but there's a hope, because we can push for technology-driven farming, and that includes moving to the space. Vertical farming is one of the solutions. I will explain that later on. So on the left-hand side, what you see is evolving and shrinking farmland in Singapore. Yeah. So the top panel is a situation at the independence of Singapore. We have about 25% of land for farming, but because of the drive towards industrialization and urbanization, we now have lesser and lesser, 1% as I mentioned. The second one, I think more important, is food waste generated in Singapore and around the world. This is something like I always share this with analogy of tap water. If we keep the tap open, we don't use the water, it will never be enough. Likewise, I do not think we should simply push one direction for primary production. We also need to address the food waste problem. There's a survey by FAO which indicated that if we can reduce food waste to zero, there's actually no need to introduce GM crops. So that is in the case of Singapore, this is the amount of food waste we generate every year. This is a yearly situation, and the problem is actually made worse because we do not have animal farm to channel any of the food waste. So what we do is we just burn. That consume a lot of energy, and the ashes that we send to land reclamation, there's a capacity constraint too. So by 2035, if we do not have any solution towards food waste reduction, we cannot find anywhere to dump the ashes anymore, right? So this is an acute issue that very few people pay attention so far, but now of course it's a different situation. Everybody talk about food waste reduction, but at the time when we started this endeavor in the food space 5-6 years ago, no one talk about it. The third one is the aging population. For those who have been to Singapore, you know that this is a very fast aging population. People work very hard. There's not much time for dating, getting married, let alone having children. So aging population reflect the different set of nutrition requirements. So when we combine all three elements, we can see that it's never food security. Food security is never just about making food available to Singapore. So the solution, there are some solutions that I mentioned for the primary production. We talk about smart farming. Urban farming is an option, important option, although the cost is high, is an important option because how do I put it? It was estimated that more than 70% of the world population will be living in the city area, urban area in 30 years time. So developing smart farming, urban farming will be required. Yeah, and then the demand will drive supply. So in time to come, the cost will lower down, right? Second one is the processing technology, how to reduce food waste. This is where we come in. First one is to reduce the generation of food waste. Second one is to take nutrient out of food waste. So we create this zero waste food circular economy situation. Nutrition, as I mentioned, the requirement is different for the elderly. Why we move into this processing technology area? Because in Singapore, we have other pocket of excellence for the other two. So it's a small country with I will not say limited resources, but there's no point duplicating other people's effort and create competition. So we move into an area that no one talked about 5 years ago. Now, of course, as I mentioned, everyone talk about it. This is a snapshot of our food science and technology program that Fariba and Sandra have visited. There are two components, education and research. I would focus on the research area. In the education, I would like to highlight that we have a partnership with Dutch University, Wageningen University in Research, but we do more than working with Wageningen University in Research. We moved the food science education into the secondary school, junior college level, so much so that today, this year, the #1 secondary school in Singapore, Raffles Institution, started offering the food science and technology course. This is something that unheard of in Singapore, because food technology is never a top choice for the kids. So I moved to research side. When my university asked me to run the partnership with Wageningen, they were expecting me to focus on education. But I thought that to give identity to the education part, we ought to develop research. But I did not have much funding support at the time. So we look for simple technology, and because of the lack of funding, and also sort of cost effective, because no money. But looking back, our innovations turn out to be a big draw for industry, because it's low cost and simple. The scalability is very high. So I will talk about, briefly mention our collaboration with government and industry engagement later on. And I'd like to highlight that our drive in the food waste reduction area now is gaining traction. So much so that the Nobel Prize for Peace was awarded to the World Food Program this year. And the food reduction, zero waste, is also actually the motto for the World Food Day this year. Okay, this is summary. I understand I only have about 15 minutes, so I will just give you a summary, but I will welcome all the continued interaction after the conference. So basically, how do we talk about circular economy? So here you see there are two steps. Simple. First is a fermentation. Second is a green extraction. Fermentation, we started with this side stream from food processing, simply because they are homogeneous in nature, so the scalability is high when we develop any innovation. So we have this soybean residue, pure spent green, and with cooking oil. Why we work on this research area without any collaboration with Wageningen? Because if you go to the Netherlands, everybody is 2 feet taller than me. I'm 180. That's because of the nutrition, right? Difference in nutrition and diet. So there's no point doing something that no relevant to Singapore. So we work on problem of relevant to Singapore. A soybean, pure spent green. Not that we drink a lot of beer, but this is also barley green. Is also something we make for local beverage called Milo. Okay, so applying fermentation allow us to take a nutrient out of this waste, but there's a large proportion of insoluble fiber in this residue. So we have developed extraction technology to take cellulose out of it and then convert into biodegradable cling film. And in the area of extending shelf life of food produce, we have developed natural food preservative from plant, but produced outside the plant. And these are much better than the chemical food preservative that, which are being used in the processed food. And to our surprise, there are also other applications in the area of preventing the spread of COVID-19, because one of the companies simply licensed our technology for the antimicrobial compound and put into the antimicrobial mask distributed in Singapore. And I just show you two examples of our fermentation application of fermentation technology. One is this has led to a large industry innovation lab. So this is a F&N, local beverage company, which has been around for 140 years. We were a 5-year-old baby, and they have decided, instead of working with others in Singapore, to work with us. So they opened the innovation lab, working on multiple projects over multiple years. This is a big, nice surprise to us. This is just one of the examples of our industry engagement. The below feature shows that our fermented product can also be applied to urban farming setting. In this case, we talk about protein-rich microalgae. Our fermented product can replace the microalgae culture medium and allow the microalgae to grow without sunlight. So this is a breakthrough in the sense that one day we may be able to decentralize the urban farming setting at a household level. On the bottom right corner, what you see is our packaging technology, which has been to the final of the Temasek Foundation event called Livability Challenge. And this is about the biodegradable clean film. I'd like to also draw your attention that our technology developed in Singapore, NTU, largely platform in nature, which means a fermentation can be applied to various raw materials, and the cellulose extraction can also be applied to various high fiber content raw materials. Yeah. So these are some detailed examples. This one I have shared with you, reported in the Straits Times local newspaper, microalgae farming with our fermented product. In the middle is some tropical fruit called durian. In Singapore, we consume 12 million durian a year. It's enormous, but the only thing that is edible is the part in yellow. So you can see 80% of the fruit go to the waste. So what we have done is that we apply the cellulose extraction technology to the durian husk, the shell, to make clean film. And the seeds we have made by a simple technology into emulsifier and food stabilizer. Right? And at the right bottom corner, you see our natural food preservative endeavor. So this is very much in demand by food industry. So due to time limitation, I just share with you our impact of our innovation. We do publish in papers, in good journals that include the journal of food chemistry. For the packaging part, we publish in Food Packaging and Shelf Life, and we also publish in Journal of Agriculture and Food Chemistry, and among other Journal of Functional Food. For those who are interested in the further interaction with me, I include two links here at the bottom. And our simple technology and scalability has attracted a lot of investment from food industry, so much so that my research lab is entirely funded by food industry. These are pretty unusual. Attracted a lot of, so this is our education setting, only 3 support staff. Also attracted a lot of media attention. So we have been interviewed by Bloomberg, Wall Street Journal, CNN push out a program called Going Green, highlighting our cellulose extraction innovation. We have been interviewed by other news outlets, including Japanese, BBC, and the AFP.
Fantastic achievement, Professor Chen.
This is my last slide. Yeah, this is my last slide. In terms of government engagement, we are running this Singapore food story at the NTU. The third pillar of the Singapore food story, 33 million Sing dollar, to develop risk assessment for novel food, and also educate public and consumer to be more receptive towards novel food. Otherwise, we produce a lot of food through urban farming, but no one buys it, so we are wasting our time. So this is my last slide. I promised Diana. So this I will stop here.
It's all good. There are a few questions for you, and also there are some questions outstanding for Pablo and Victoria and Fariba. So quickly, please, with the answers. Chris Ross, amazing to hear about the durian, Professor Chen. Why do you think that young people, the generation most interested in sustainability, aren't interested in pathways to food security and innovation? This is the first question, and there's another one after that. You can answer this.
Sorry, first one was, please repeat. First one is why the younger generation, and please repeat.
Is why the younger generation that is interested in sustainability is not interested in pathways to food security and innovation.
As I mentioned, I'm not sure about the situation in Australia, but in Singapore, it's about awareness. It's about awareness. When we were promoting food technology in the secondary school and junior college, they are interested in the food security, but they don't know what is it about. So I believe it's about promoting the awareness among the younger generation. Yeah, and as a matter of fact, the top school student now, they are sending the brightest student to our program to start to move to do food research, and they win an award at national competition level. So with time, things will change. Yeah.
There's another one, maybe a remark from Shi Ji Sung. Thank you, Professor Chen, on your presentation. I'm from Malaysia, and I do not eat durians, but I will use your point on 80% ways to encourage family and friends to stop consuming the fruit. Also have watched a few programs on Channel News Asia, Singapore Innovation in this space. Very excited, also very encouraged to see community gardens in the apartment blocks. Many people...
Very good. This is just in line with, not I'm driving it, but in line with what we are doing in terms of microalgae culture. So if we can do away with sunlight, we can develop a affordable, low-cost culture medium. So there's a hope that community gardening is not limited to vegetables. We can go beyond that. Yeah.
We have only 1 minute for question answering. Fariba, in the area of sensing food ripeness, have you had any success with use of image-based artificial intelligence sensors? Yeah, just one word answer, please.
The focus of our research is on detection of gases, and we are not working on imaging. No.
Yeah.
So my colleague work in that area.
Yeah. For Victoria, have you developed a product prototype to replace plastic that is fully home compostable?
Oh, sorry, a what that's fully compostable?
Plastic.
Is there one? Well, PHAs are pretty much fully compostable. Some PLA, so PHAs are the polyhydroxyalkanoates, to a large degree are compostable. And in some situations, or many situations, as I understand it, polylactic acid-based plastics are also compostable. So there's at least 2 types.
Yeah, and there is another question for Pablo, which I just lost. Sorry. Was in a chat, but I lost it. Sorry, Pablo, but there is another one. As food waste is unstable, how long in days may be available between waste supply and processing?
Yeah, that's a very difficult one to generalize. It varies. It varies on depends on the raw material, and and if it's a fruit material, if it's a meat product. I mean, it depends on the water content. If you have a dry product, it's a different story. So yeah, but the idea is to inactivate bacteria, inactivate enzymes, stabilize it through thermal processing or other processing, and then take it forward. So the more stable you have that material, then it's easier to handle the logistics of it and get it to the next step.
Thank you so much. I would like to thank all of our distinguished speakers, Dr. Pablo Juliano, Associate Professor Victoria Haritos, Professor Fariba Dehghani, and Professor William Chen, and all our audience. Thank you for being with us. At the end of the year, we want to wish you Merry Christmas and a happy, joyful, and especially healthy New Year.